We want to find the domain and the range of this function. Domain: the square root is only defined when the expression inside is greater than or equal to 0 and the denominator is not a 0, because if the denominator is a 0, the expression inside will be undefined. Let us factor the numerator and the denominator. That means our x squared minus 4 all over x squared minus 1 equal to x minus 2 bracket x plus 2 all over x minus 1 bracket x plus 1. Set the expression inside the square root greater than or equal to 0. Our x minus 2 and x plus 2 all over x minus 1 x plus 1 is greater than or equal to 0. Find the critical point. And for us to find the critical point, we have to set the numerator and the denominator equal to a 0. That means x minus 2 bracket x plus 2 equal to 0. X minus 2 equal to 0. X plus 2 equal to 0. That means x equal to 2, x equal to minus 2. Also, let us set the denominator to 0. X minus 1 bracket x plus 1 equal to 0. That means x minus 1 equal to 0. X plus 1 equal to 0. That means x equal to 1 and x equal to minus 1. This critical point divide the number lines into intervals. Now let us perform a line test to determine the intervals that are included in our domain. And our intervals are based on our critical points that we got: -2, -1, 1, 2. And our intervals are -infinity, -2. Here again, -2, -1. That means from this point to this point. Here again, -1, 1, 1, 2, and 2, infinity. Let us draw a table for more clarity and simplicity. Interval. Here, this point, our test value, where from here to here is our sign of each factor. Sign of each factor. Here is our result. Now let us pick our test value between negative infinity and minus 2. We can pick minus 3. Our x equal to minus 3. And between minus 2 and minus 1, we can pick minus 1.5. Between minus 1 and 1, let us pick 0. And between 1 and 2, let us pick x equal to 1.5. And between 2 and infinity, let us pick 3, x equal to 3. Let us insert minus 3 into this inequality, and let us insert it into each factor and check their sign. Now if we insert minus 3 into this one, it will now be minus 3 minus 2. We are going to have minus 5. That means our sign is minus. Let us put minus. If we insert minus 3 here, we have minus 3 plus 2. We are going to have minus 1. Our sign also is minus. Now if we insert minus 3 here, minus 3 minus 1, we are going to have minus 4. So our sign also is minus. If we insert minus 3 here, we are going to have minus 3 plus 1, which is minus 2. Also our sign is minus. Minus multiplied by minus, we are going to have positive. Here also minus multiplied by minus, we are going to have positive. Positive divided by positive, we are going to have positive. That means positive value is greater than or equal to 0. So this interval is included. Let us repeat the same procedure for the remaining ones. Now our complete table is this, and whenever we have positive as our result, that means that that interval is inclusive. For example, this one is inclusive, this one is inclusive, and this one is inclusive, and this one is not inclusive, this one is not inclusive. Now let us locate the interval. Our first one, we have already marked it. This one is not inclusive, this one is inclusive, this one is not inclusive, this one is inclusive. Note that we must include the values that make the expression is 0 when the numerator is 0, but we must exclude where the denominator is 0 because this will be undefined. So our domain is negative infinity, minus 2, square bracket, union negative 1, 1, union square bracket 2, infinity. Minus 2 and 2 are the values that makes our numerator to be 0, which is valid. But when our denominator is 0, this expression will be undefined. So we have to exclude minus 1 and 1 from our domain. We want to find the range of the function. We know that square root is always greater than or equal to 0. So the largest value of the function happens when the square root is smallest, which is 0. And that happens when the numerator is 0. When our x equal to -2 or x equal to 2. At those points, our function of x will be 1 minus root 0, which will give us 1, which is our maximum value. Now let us check the minimum value. As x tends towards -1 from the left, or as x tends towards +1 from the right, the denominator gets very small, but the numerator is not 0. So the whole fractions get very large and the square root goes to infinity. So our function will now be equal to 1 minus root very large. So the whole function will now tends to negative infinity. So the function decreases without band, and our range will now be -infinity, 1 square bracket.